one of our largest customers would get one component manufactured in like close to 30 hours. 30 hours to make that very complex component. We make it in 7 hours. But there was one particular scheme by the central government where the government would pay the fees to those patent attorneys and we would have to pay just like 8-10,000. Look, the only thing I would say we could have done differently is run multiple experiments in parallel rather than go sequentially about it. At Ethereal, every year, we manufacture components for these racing teams in colleges pro bono.
Hi, I'm Apurv Shankar and welcome to another episode of The Hardware Story, a podcast wherein we decode how to build hardware ventures. The next decade is going to be huge for India's manufacturing story, and we need more founders to build their hardware ventures out of India. The idea here is to make it simpler for anyone who's starting out their hardware venture and learn from the experience of folks who've done it before. Our guest today is Kaushik Mudda, the CEO and founder of Ethereal Machines, a Bangalore-based company which builds its own multi-axis CNC machines and caters to different industries across the world. Welcome to the show, Kaushik.
Hey, Apurv.
Let's just get started with how you started, a little bit about you, and then the company introduction.
Sure. So we've actually been doing this for a while now. We actually just completed a decade of Ethereal Machines. And also welcome to our factory. I think you've come in at a time when we have enough space to record this. And probably a week or 10 days more, all of this would be occupied with a bunch of more machines that we are building. So yeah, welcome to our factory. So we've been around for 10 years. I started the company in 2014 with my classmate Navin Jain. Both of us went to engineering together. We were hardcore tinkerers, I would say. We would break open things, remake them. We would build a lot of robotic arms, quadcopters, small drones for no particular purpose as such. It's just for our own amusement, And mostly what we would do is we would use components from something that we've broken and retrofit them, mishmash them together, and then get something up and going. But then when we were in our final year, and finally it was pretty much like no classes, it's just your project, right? And when we had a little bit more free time on our hands, we wanted the robotic arm to stop at 40 degrees instead of 45. We wanted the quads to fly a little higher. Again, no particular purpose as such, just for our own kicks. But then we realized, okay, if we want to achieve all of this, we need access to something called the CNC machine. Right? CNC stands for computer numerically controlled, where basically you feed in a code to the machine, which is basically in the form of coordinates. It's like how you plot graphs in school, right? You have your x and y. So if you have to go from 2,3 to say 8,10, then there's like a path that gets created. Very similar. The machines have coordinates in 3-axis and in 5-axis, in 5 dimensions and in 3 dimensions, where the machine knows which point to go to next. That's what CNC stands for. So the computer understands all of this. So you feed in a block, a billet of materials. It can be metal, it can be wood, it can be engineering plastics. Say whatever materials out there, right? And the machine will give you the final output of the design or the component that you want to produce. So when we wanted to make the quad fly higher, or we wanted the robotic arm to stop at that particular angle, we realized we needed more precise cutout parts. Now to get more precise cutout parts, you need access to a CNC machine, or you just own a CNC machine. Right? And like how you would imagine any 22-year-old or 21, 22-year-olds, the hubris was so high, right? They're like, yeah, we just go buy a CNC machine. And within like a couple of days, we realized that, okay, we can't afford a CNC machine. That's not happening. We said, okay, the industry even today has tens of thousands of mom and pop job shops, which have like 2 machines, 3 machines, 5 machines, 10 machines at maximum. You can go to one of them, give them your design and say, make my component and give it to me. Now here are two like final year engineering kids who's asking a vendor to manufacture who has like 2 or 3 machines, who's already backlogged by a few orders that he has. And our quantity is what? Just one piece of piece, right? It's not a commercial application. We're doing this for our kids. So now when we want that guy to manufacture 1 or 2 components for us, he's quoting us an obnoxious amount. And we don't want to pay an obnoxious price for just 1 or 2 components. Or he would say you come back after 2 months. And I would say I have grown more impatient with time, but I was pretty impatient even then.
This was all during the final year, or
This is just around the final year, like early 2014.
and this was for your final year project?
No. Final year project, we chose something easier. this, this was happening on the side. So we said, okay, look, we're not going to get our parts within less than like 2 or 3 months. He's quoting us obnoxious prices for just like 2 parts. We can't buy a CNC machine. So what do? We said, let's just make our own CNC machine. Simple, 3-axis. So it literally started as a problem that we were facing ourselves for solving like some of our own engineering quirks. So we said, okay, let's just make a 3-axis CNC machine. Again, just hubris. They're like, how difficult can it be? We'll also make one.
Quite an ambitious dream already, man. For folks who are still in college, thinking of building their own CNC machine itself is a big thing, man. Even the thought.
No, that's the thing, right? We didn't know how hard it would be. And nobody's done that much. Nobody's done this in India, right? So nobody was telling us at that point in time at least how hard it is to build one. So like, yeah, we'll just make it. So that's how it started. So we started building our first machine in one of my friend's flats. Then we moved to a small garage when our friends had to kick us out. We did a small 3 feet by 2 feet CNC router. It's a simple 3-axis machine, moves in X, Y, Z. So you can cut out like a plane or whatever. And that's what we needed at that point in time. Within 3 to 4 months, Navin was able to get a huge amount of like headway into making this machine. And once it was done, we started cutting out some of these parts. We're like, hey, not bad. Like, the accuracy seemed to be good. The machine's performing well. We're able to cut out all of these parts. So if we face this problem, pretty sure a lot of other people have faced it as well. There was a time of ads on OLX and Quicker. They were all like booming. So you could post a lot of free ads. They were just taking off. So, 2 phone numbers, you could probably post like 15, 20 ads. So we just like posted ads all across the country. And a lot of people started following up and saying, would you actually want to buy this machine? So, and this was just around the time of graduation.
Wow. And you were doing this, you were cutting metals at that time as well, or some other parts?
Very light metals, but it was mostly wood that our first machines went out for.
But the technology, as in code wise, should remain fairly similar to cut wood or cut metal, right? Yeah.
It's the machine rigidity changes if you want to cut higher metals. The tools that you choose, that changes. Maybe the coolant system that comes in. So it's more of the mechanical side rather than on the code side.
Got it. Very cool. And when you started this, did you think of it as a business venture, or it was more like, let's see where this goes? Or how did you think about that?
No, so that's one thing that, so both Navin and I come from families which have been in some kind of business or the other, not manufacturing, of course, trading. In my case, like my father was in the cement industry, which is generally a business mentality. There's been some kind of an influence to both of us when we were growing up. And we always used to speak since like second year. We always spoke that, hey, we should set up something of our own. We always speak things like that. But we've always had that kind of like, we should try and build something of our own. So that was always there.
Got it. Very cool. For the prototype funding, did you require any funds separately, or you guys bootstrapped it and got it done?
It was a good amount of journey after that, right? Like this was still just the first. So, and this was still, we're still at the 3-axis story. I'm not even touched the 5-axis part. So Naveen used to go for a couple of these robotics competitions in college. And I used to do a lot of these debating competitions. So both of us had a good amount of prize money stacked from both of these competitions. Not a huge amount, but it was enough for us to build our first prototype, which is like a lakh and a half ish. And I think I had won somewhere around 80, 90K. Naveen had won like a similar 50, 60K types. So we just put that in together and built the first prototype in that amount. So for us, it was also like the first prototype has to be made only in this much amount. We don't have more than this, right? And we don't want to go back home and ask, like, because we still like to complete our engineering and things like that. So we're like, okay, that's the door that we shut day one, which we never tapped again. Never went back and asked anything. So you're like, okay, we have to figure out how to make a 3-axis CNC router in this much money. So that's what helped us. But then post like when we were selling these machines, right, 3-axis machines, it is usually against an order. So customers would pay us a good 50-60% of advance when they were placing an order. And then the remaining would come after delivery, which is in like 45-60 days or upon dispatch. And then we used to have the credit period with our vendors, etc. Which kind of took care of it. So we bootstrapped it for like 2.5, 3 years now.
Oh, nice. And so you didn't require any special materials or components to source to build this, or all that was fairly easier as compared to.
No, nothing special on a 3-axis. It was low precision. It was just like, the applications here were people who were etching something on wood for their like doors, house doors. Somebody's etching nameplate on marble. Somebody's cutting like the outer chassis of an EV. Right? We went up the application ladder. Somebody, in fact, was even cutting out like the outer just like some part of a yacht, like on a larger 4 feet by 8 feet machine. But none of this requires high accuracy. It was like a cutout. So there was nothing, heavy in terms that we needed to, in terms of our capital expenditure to maintain or get high kinds of precision, which we have to do now. Because now we've gone at the highest end of spectrum of uh, machining and accuracy.
And then how did the journey evolve from that, starting with majorly wood cutting applications, to building, let's say, the current machine that you're building? How did that journey take place? Like idea wise, when did you decide that now let's take up a bigger challenge and do this?
So, so 14, 15, we started selling these machines. It was a little bit difficult initially, but when we went about it, people were buying. We sold good machines in like double digits all across the country. We sold machines in Jammu, Punjab, Kerala, Northeast India. We didn't leave anything. We sold machines all across these places. Now, somewhere in like 18, like we were, well, this had kind of become like, we could have built these machines with like our eyes closed. We weren't upgrading technologically on these machines. And there's another thing which we noticed, which people are noticing now, that like we kind of saw a trend earlier on because we were in the industry. So to make this relatable to you and the viewers, right? So just look at the thickness of our TVs in the last 10 years, how much it's like reduced. If you look at what goes on in a engine in a automobile, it's kind of it's shrunk, right? So what's happening is across industries, products, components are shrinking in size, but at the same time they're becoming more complex because they have more features, they have complex machining operations, they have operations on different pieces. Like if you think about a cube, right? Like what would have ideally just been like a simple like cube. Now people want to have operations on each side of the cube. And like a hole on this side has like a channel connecting to something on the other side. So you got to get that operation done from all different angles. This is what engineers are designing nowadays. Because they want to make it more compact, they want to make it lighter, but the components get more complex. And to achieve an operation like this, you need 5-axis machines or you need multi-axis machines. So this is something we saw very early on, like somewhere 17, 18, that the world is going to move towards smaller components, but it's going to get more complex to manufacture them. It's going to get more precise. It's going to have more multifaceted operations, like I said, a cube in all different sides. And we said, okay, that's where it's going to move. Hubris strikes again. We say, okay, look, we've built a 3-axis. How difficult can it be to build a 5-axis machine? While we are very well aware that no Indian company has done it, we are very well aware that a handful of companies in the world have done it, predominantly Germans and Japanese. And the companies that have done it have been in existence for more than like 80, 100 years. And they have also merged, like German and Japanese companies have merged, had that kind of technology transfer, and then they have been able to come to this kind of a stage. But still, we are like, yeah, it's okay, we'll figure it out. Right? And just the two of us. More credit to Navin on that. So we're still like, yeah, we'll be able to do it. So we said, okay, so if we have to do that, then we have to, because we're a very small team, it's not like we were earning humongous amounts of money to have like a large team. We have no VC backing us. There's nothing of that sort.
But at that time, were you even looking at VCs or investments?
No, nobody, even if I wanted to look, nobody would look at us. That was the era of food delivery and e-commerce and all of that. Nobody would look at us, even if we wanted. So I never really racked my brain a lot on that front. Couple of inbounds did come, but just nobody like had like the right context to what we are building, because this is such an industry which even though is so fundamental to our everyday lives, that even today I tell them like, look, anything at this present point in time that is in contact with your body has gone through CNC machining at some point in its life cycle. Your spectacles, your earphones, your watch, those holes that you see on your shoes through which the laces are going. CNC machining is there everywhere. But still, people, the awareness is just not there. And it's like a very non-glamorous, sunset-y kind of industry, right? So there was no, we didn't have like a lot of money. So we said, okay, if we want to focus on cracking multi-axis machines, we need to shut down everything else we're doing, get to this, and we'll probably crack it in a year. And that's when we met the good folks from Bloom Ventures. That's when Bloom put in like $1 million seed money in us. Early 2019. Early 2019, January 2019, in fact, like we received Bloom's $1 million, and to their credit.
Yeah, that's also good. Yeah. Because typically in hardware, and especially in such sectors, I don't think we had a lot of VC or startup ecosystem around this, or investors super interested in areas like this. So that's I think a good bet that Bloom made at that time.
It's all credit to Grey Orange for that. It's because Grey Orange had shown a great track record that I feel that some of us got a chance to do what we are doing today. So yeah, huge credit to Akash and Samay for this. They're also angels in Ethereal. So, and Akash, so they've been great, like bouncing boards, whenever we've had something to ask. So early 2019, we raised $1 million, and we were like, we'll have the 5-axis machine up in a year, right? But it took us a good 5 years to get that stabilized. 4.5, 5 years. And the idea was always to be a machine tool builder, where we build the machines and we sell the machines, right? So like I said, the industry status quo is that tens of thousands of mom and pop job shops who have 2 machines, 5 machines. Like to give you an example, DMG Mori, who's the leader in the multi-axis industry, sells $1.5 billion worth of 5-axis machines every year. And close to 60 to 70% of their sales comes from MSMEs across the world. And they define MSMEs as companies that employ less than 50 people. So that's what we also thought, like, that's the path we'll be going now, that we'll make a good, affordable, reliable machine, which is going to be sold all across the world, and we're going to be known as a machine tool builder. So early 2019, we started all of this. Roughly around the 4-year mark, we were like, okay, this is stabilized. Let's sell these machines. This was late 2022. We sold a couple of machines. We sold a couple of machines in Italy, sold machines in Japan, sold a couple of machines in India, of course. But a very large resistance from the market in saying that how is it possible that an Indian startup company with two young founders has built a multi-axis machine which a handful of companies in the world which have been in existence for so long have been able to build. And even those 4.5 years, right, it was brutal on us because we are managing with just that $1 million. Every iteration, we have to scrape back what is left from what we can save from the previous iteration. We can't run multiple iterations at the same time. Practically, you asked me offhand, right? Like, did you ever talk to consultants?
Yeah, actually, I actually would like to understand the history of CNC machines because see, India historically in the precision manufacturing side of things has been more of a service provider, right, than actually building things from ground up, right? So, how has the CNC history been worldwide? You mentioned, earlier in a discussion about World War II, US entering it, and then German and Japanese starting, and I think all precision manufacturing started in Germany, and then I think they're still the leaders, right? So, would be great if you can just touch upon the history as such of CNC. How has it been?
So, a huge amount of development in the CNC world came up around World War II. Because suddenly everybody had to produce huge arsenals for themselves. So even today, the leader that I was talking about, BMG, they were pretty much active in Germany at that point in time. Because if you want to create aeroplanes, you want to create defense equipment, you want to create communication equipment related to warfare, such as radar, or simple just communication over long distances, everything requires CNC machines. And mostly it was like the lathes, etc. at that point in time. So what the US government did at that point in time was they told their industrial base that go ahead and start working on advanced manufacturing techniques for building slightly more advanced CNC machines. And the government promised to procure close to $500 billion worth of machines through that period. So they said, irrespective if you get any other customer or not, we are going to buy it from you. So there was a huge push. So if you go deeper into the depth of what was happening at that point in time, US literally ramped up their capacity over the last 2 years before they entered the war. So there was a huge boost on this kind of an industrialization by the government. And that's why, and Japan still really hadn't gotten into that amount of precision. So the US took that route, greatly strengthened its industrial base, and dropped the ball in the 80s and 90s. While focused more on financial services, internet, etc. So the industrial base depleted there. And that's when Japan picked up the ball from there. So then the Japanese started putting in more and more research and developmental funds and energies into CNC machinery. So that's why today the best CNC machines come out of Japan. And then they merged into a couple of German companies. Germany was stripped down of a lot of these things, but still the precision levels is something they still somehow managed to keep. But even today, both German and Japanese companies are not allowed to sell multi-axis CNC machines or 5-axis CNC machines with anything that has gotten close to do with defense or nuclear. So if you notice, like a couple of months ago, India intercepted a 5-axis machine that was going to Pakistan via China, via India, but it originated from China. And it was disguised as something else.
The governments don't let you procure 5-axis CNC machines itself.
It's generally a very controlled thing with multi-axis.
Oh, wow, really? Didn't know that.
It's generally a very controlled thing. If you want to go about purchasing a true simultaneous 5-axis, it's a very controlled, very controlled environment. Another interesting bit of history on CNC machines, which a lot of VCs ask me saying, hey, Chinese players will come in and copy, whatever. So the thing is, China is so good at manufacturing and so powerful at manufacturing that every year China is not able to produce enough CNC machines for itself.
Okay.
They manufacture a couple of $1 billion worth of CNC machines every year, consume it themselves, and are also the largest importer of CNC machines from Germany and Japan.
Wow. That much manufacturing.
Yeah. So if you were to look at the Indian CNC ecosystem, we have 3 or 4 large players who are doing 1,000 crores a year. AMS, BMW, Jyoti CNC. These are 3 largest players. But predominantly people rely on them for 3-axis machines or 2-axis machines. That's what people end up buying from them. And there are not a lot of, so predominantly people are looking at them for 3-axis machines, and there are no 5-axis or multi-axis players. So what people usually end up doing, the ones who want to do multi-axis, usually end up purchasing a machine that's built outside India. So they'll either buy a Japanese machine or a German machine or an American machine. So if you want to go on the mid-level precision, people will go and buy a Haas multi-axis machine. Haas is the same Formula One team. They build their fortunes in CNC. One of the largest CNC players in the world. And if people want very high-end precision, they either go to a DMG Mori or a Mazak. That's what people usually end up buying. And that's where we saw that, look, these machines are extremely expensive. So rather we should try and build this from scratch ourselves and, let's put this out. We start putting them out. People are like, this is not possible. They're seeing the machine working. They're seeing it producing parts. So they're like, look, we don't know. So they'll be like, why don't you park the machine with us? And we'll pay you after a year. I mean, I'm going to die. I have survived on $1 million and a half. I reached a small bridge round. I'm going to die.
But are there actually companies who will let that happen? That you get a machine and then you pay after a year? Does that really happen? No, right?
No. That's, I would know. No way. No. I couldn't have. I would not have agreed to that. I never did. I said, okay, look, this is not working out. Cool, we can sell a couple of machines here and there. It can be a small scale business. We're not gonna truly die in it. It'll work. You can be bootstrapped, you'll manage. But is that the intent here? Right? That if we've built such a great technologically advanced product, and we're the first Indian company to do so, we are seeing the output because we are running this day in, day out. We've designed every bit of it. From end to end, what's gone into the machine, how the innards look, how the exteriors look, how even the coolant is flowing, how the waste of the metal chips is getting out. We've spent nights and nights understanding each of this. I mean, this deserves to have a far greater impact.
For people who are new to manufacturing also, what is the difference between 3-axis and 5-axis machine?
Sure.
In very layman terms.
Yeah. So, see, this is something I have to manufacture now. So what happens is, in a 3-axis machine, my machine will go X, Y, and Z. So I will cut out this square. What about the dial here, the crown? I can do the top half of it. There's no way the machine can do something here. It's just not possible. It can't reach the bottom half of the crown. Or it can't reach this side face if you want to write your name on it. See, a simple thing. What happens in a multi-axis machine or a 5-axis machine is, once a component is held like this, and this entire square, the machine will move X, Y, Z, it will cut out the square. Then the table will tilt. Once it tilts, you have access to this side of the particular. So say that's better. I tilt it. Once I've tilted it, I have access to do an operation here. What if I want to do something on the diametrically opposite side? Then the entire thing will rotate and give you access over here. So your tilt and your rotate are your fourth interest axis. Now, what does the industry do today? Because this still gets manufactured, right? And the world is filled with 3-axis machines. It's not filled with multi-axis machines. What does the world do today? Once your entire operation here in X, Y, and Z is done, you will stop, pause the machine. You will take this out and you will place it like this. And then you'll do your operation here. You will stop, pause the machine again, take it out, and then put it like this. And then you'll do your operation here, take it out, throw it. This in our industry is called something called as multiple settings.
And of course, it's slower.
Yes. One is slower. But when you're talking about what we deal with today is very high precision. When you're talking about such micron level precision, you are looking at a rejection of 6 out of 10 components. Because every time you take it and you set it back, if that reference point is not captured to the last micron level, your tolerances will go for a toss. It's okay if it's a showpiece.
Yeah.
If it's like a toy or something like that, it's okay. Their precision doesn't matter. Right? But what we do today are components that go into engines of aeroplanes, components that are going into structures of aeroplanes, the components that are going into like healthcare devices. You can't afford that. So to give you an example, one of our largest customers would get one component manufactured in like close to 30 hours.
How large is this component?
This is like a 100 mm by 120 mm type. Very small.
Oh, wow.
It's this much, like literally the size of both my palms together. 30 hours to make that very complex component. We make it in 7 hours. Simply because we don't have to keep setting this again and again. Nobody has to interfere in the manufacturing process. So we've dropped this production time by 1/4. We've cut it down by 1/4. And that's one of our largest customers today. We run, of course, multiple SKUs for them. So now today when we talk to customers, we just say that if you have precision engineering components, we will make it faster and or cheaper. Like the first advantage we bring to the table is faster because we have a host of CNC machines.
Right. So, how did the business model change? How did you move from manufacturing machines and selling machines to service yourself? And as you said, that most of your business is now service.
So all our business is service. We still manufacture our own machines, ground up. So when we saw that there was a huge trust deficit from customers that something like this could have been built in India, we said, okay, if you have some components, why don't we make them for you? This was one of our healthcare customers. We just started making these components. So we used to have one demo machine any which way, which was just reserved for people to come and see. It was lying idle. We said, let's put this to use. Let's start making components. We've not looked back since. We started understanding that a couple of things which weren't working in our favor in the machine selling business works very well for us over here, which is customer doesn't really have to take any risk with us now. If you have a component, they just give it to us saying, look, if you can. And usually, because we say that we're building multi-axis machines, or because we have customers are throwing at us their most difficult component. Their toughest, their most accurate component, which no other, because the vendor base otherwise is making the other 3-axis components, right? So we are getting the tougher ones, which is fine, which is great because we are able to prove ourselves there. So we work across 3 sectors: aerospace and defense, healthcare, and consumer electronics. Healthcare, we've done a bunch of components that go into X-ray machines, MRI machines. We've done some work for you. We've done some work for other players in the market who are in the wearables sector. We do a lot in the aerospace and defense side. We've done a bunch of drone components. We've done a bunch of thermal imaging. We do components that go into aeroplanes. both on the aero engine side and on the aero structural side. So yeah, so this has been something that now we've been expanding. We do some of the most precise work. Most of the multi-axis work usually comes to us because there are no other players which have such a battery of multi-axis machines. Like this place which we are presently sitting at, like this entire bay is temperature controlled. So this goes for our very high-end customers and very high-end applications. Because with every degree centigrade change, your part accuracy differs. It material expands or contracts by like 1 to 2 microns. Now imagine an application for 1 to 2 microns. I can't talk much about what we are doing in this particular way.
But I understand the pain. We've been through something similar wherein small temperature change would just completely get the product bad. Yeah. On the business side of things, considering your previous business model, wherein you were selling machines to folks, what advantage would they have if they take your machine instead of, let's say, a German or Japan made machine?
It's two things. One is we've always made very compact machines.
Okay.
So a lot of these SMEs, MSMEs are very short on space. So we always wanted to build a very compact machine which can house and very user-friendly machine. So like if you've seen our machines, like we tried like a 12th pass or a diploma or ITI candidate pass can run my machine in 1.5 days of training. And these are 5-axis machines. It's unheard of because these guys, the operators who get out of ITI diploma colleges, are mostly only trained on 3-axis machines because even those colleges have just 3-axis machines. And to convert from 3-axis to 5-axis is a very complex piece of tech to be able to run. We've simplified it so much over 4 years or 5 years of talking to like these operators, different MSME shop, machining shop owners. There's a huge advantage in terms of user experience and in terms of cost as well. So these machines, when you're selling them, you 1/3 of what they would have had to pay for a DMG Mori or any other, not just DMG, like any other, are very similar in terms of throughput, very similar in terms of accuracy. We've in fact our latest machine, our latest generation of machines. In fact, that is not something that we sold or was out in the market for selling. This is an improvement that we've just done. Our latest machine has been hitting positional accuracies of like 2 microns and repeatability of the same amount. This is the first for any Indian CNC company. So the amount of accuracies are through the roof right now with our machine.
I mean, continuation to that, how many components do you have to build? You have to get to build one CNC machine, your 5-axis.
Anywhere between 400 to 450. Yeah.
And do you also machine a few of these components yourself? Yeah.
With the kind of accuracies we are hitting, there are no vendors outside who are equipped with that kind of machining skill set. So on my ambient temperature base, there are 2 of my machines which are reserved for just producing parts for the next batch of machines.
Right, very good.
Not reserved.
Yeah. Machines making machines. And that's how that's how it should be.
That's literally what it is with us.
Let's get to the IP part of it. Did you file any IP? Did you get any support from government grants, something like that? Because you're too deep in manufacturing. This is like deep tech in the true sense. So did you get any support like that? And have you filed IP? How much focus have you been on IP as such? Do you see any value there?
So we've got a lot of support from the government for this, especially in the IP regime. We filed for a bunch of patents back in like 1819. We filed for a bunch of patents, and there was a time when Make in India, Startup India came out with like a bunch of IP facilitators. Look at that point also again, it's not like we had a lot of money. And I engaged with like a couple of law firms to file for IP. The fees were ridiculous. Like at that point in time, I couldn't even think of like spending that kind of money to even like protect the IP. We just couldn't afford it. But there was one particular scheme by the central government where you could, it's called a patent facilitator scheme, where the government would pay the fees to those patent attorneys and we would have to pay just like 8-10,000. So that was very, very helpful for us. So we filed a bunch of patents through that route. Uh, but of late, we've been trying to protect things more internally. Uh, we've of course engaged a couple of more lawyers now. We're filing for a couple of things, but the focus also is on encrypting as much as possible. Um, but also, it's just a super hard thing to replicate.
Correct. Yeah, that's also there. So you have to always have a trade-off and how much time do we spend on IP. Yeah. And then I think since your new business model is more about service, then your machine doesn't go anywhere out as well. Yeah. So you still have that protected.
Look, I'm happy if somebody actually makes more multi-axis machines. The country needs it right now.
Honestly, like for a few things, I feel if they have actually been able to build something like this, they actually deserve some credit there too. Yeah. Right?
Like Navin and I joke about it sometimes, right? We're like, look, as a, if we were to become, if we are to become a $5 trillion economy, we are not going to be able to do it as a country via the services route. That is not happening. It has to be via manufacturing. And if you want to do that via manufacturing, you can't be on the lower end of the spectrum of manufacturing. You have to be on the higher end of spectrum of manufacturing. Now, if you want to be on the higher end spectrum of manufacturing, and the country doesn't have good CNC machines or doesn't have multi-axis CNC machines, then you're not going to get there. How many machines are you going to import? Right? It's exorbitantly costly. It's very expensive. That's why the manufacturing base power isn't existing. It's not just about getting the machine, right? Like now, as I'm scaling this business, I understand there's a lot of manufacturing engineering talent that needs to be focused on. The loss in translation between your manufacturing engineering team on how to produce a component, what tools to use, which phase do you start the operation on, to what the production team actually does. That loss in translation needs to be minimized as much as possible. You can't afford a downtime of even an hour because there's so much demand that the country is seeing right now that to be able to cater to it, you have to optimize every single minute of it. There's so many more challenges that the country needs to solve right now in terms of manufacturing. So does Ethereal too. That most of our time goes in these kind of problems as of now.
Yeah, I get it. Got it. Cool. I wanted to move on. Wanted to get more details on your building journey. So, of course, one primary idea here is to help younger founders build or learn from experiences of people like you who've built such ventures, right? And of course, you've done a lot of hit and tries. Something worked, something didn't work, and then you spent the last 10 years in building this to what it is today. So, wanted to get to know more about your building journey. Where do you think you made some mistakes? What would you have done differently?
Look, the only thing I would say we could have done differently is run multiple experiments in parallel rather than go sequentially about it. But this is also a function of capital. And I'm glad that's changing now. Right? Like, I am pretty sure, and I was talking to, VC asked me that, like, oh, we took that much time. I said, yeah, but like, if I had 2 million versus a million, so I'll tell you, right, before our first stable 5-axis machine came out, we went through 12 iterations. And if you ask me today to show me those 12 iterations, I can't show it to you. Why? Because the first iteration, whatever I could salvage, I've taken it out and I put it in the second iteration. So I can show you the 12th iteration machine, but I can't show you 1 to 11 because I have stripped whatever I could from 1 to 11, put it in the 12. I have sold whatever was not of use as scrap and taken that money per kg and invested it back into the 12th machine. So I wish I could have just run some of those experiments in parallel because we knew that, okay, if this doesn't work, we know that this is the next step. But I can't, but maybe this will work too. Maybe the path B will also work, but I don't know for sure. So should I just jump to path C? No. Because path B is cost efficient. So I had to run path B before I go to path C. If I had more money, I would have done path B and path C together.
Right. I think this parallel approach of getting things done. We all sort of learned more at Ultra Human. Prior to that, we were also majorly bootstrapped. Me and Yogansh when we were running our own company. But then at Ultra Human, we sort of learned that the speed is what matters, and that's what keeps things exciting. And you can use capital as a tool to ensure you're actually getting to a result, and that's what's actually important, right? So completely line on that approach.
Like to give you an example, right? To get a little bit more technical, so what's different in our 5-axis machines is we build our own rotary table. Nobody does that. We build our own automatic tool changers. Nobody does that. People buy an automatic tool changer from somebody, they buy a rotary table from somebody, put it together and then sell it. But we have to build it in that certain budget. Now in the rotary table, we first went through a worm wheel drive, but today we are at like a direct drive. But we wanted to check if the worm wheel works first, and then we go to the direct drive. But we can't do this both parallel. Or we couldn't do it back then. Today we are in a place where we are running a lot of experiments in parallel.
Yeah, I think that's the right way. For hardware manufacturing, I think it's anyway a problem, right? You can't iterate very quickly. That you need those parallel approaches working. Software is comparatively easier. 2 weeks I spent to build something. I wrote something right. I'll correct it in a week and figure it out. Right? Hardware, of course, you have dependence on other, let's say in the whole supply chain as well. Some part must be coming from some other place. And if some change is required, you have to wait for that to come to move to the next step. So that's anyway a concern.
It's like this, right? Like if that one bolt is missing, your engine cannot be started. It just can't be started. So even for the smallest part, everything else gets delayed.
Considering you're building machines which are highly technical in nature or would be considered true deep tech in a way, did you onboard any consultants who had some experience in building something like this? What did they tell you about this business?
Yeah, they all had the same one single advice to us: give up. Wake up. It's just like give up. This does not happen in India. You cannot build 5-axis machines in India. This doesn't happen. And finally, so one of our investors was telling me, because when they were doing the due diligence with us and they were talking to external industry consultants, and they said that there's a company, is doing multi-axis machining, 5-axis machining in India, and the other side is like impossible. It's not like that company doesn't exist. So we barely got support from the ecosystem. It's practically non-existent. So it's literally been like us just ramming at the problem again and again and again.
But then, did you also reach out to them once you actually build it? No?
There's so many headaches here, man. To do that, so many headaches.
Really hope they know about it. Nice. Now, specifically wanted to understand more about your fundraising journey. How has it been? The first few years, of course, you said you bootstrapped, your award money was used, and then the business started running, you're getting some cash, then Bloom invested, but then how did it go forward from there?
So Bloom put in like $1 million at that time. We lived frugally.
And there were no angels.
Along with Bloom, like the founders of Grey Orange, but along that.
Got it.
So they were, even today, like whenever we see some strategic angels, we ask them to help us out. So after that era of like getting Bloom's money, we had to figure out how this is going, etc. We shifted to the mass model, which is machining as a service. Right now, when we moved to machining as a service and the business really started like taking off, that's when we had a bunch of interest. And people started understanding And I think that was also the same time that the India manufacturing story started gaining traction early 2023, early to mid 2023. So we've had two rounds happen in a year now, back-to-back rounds. The India manufacturing story is something that is showing a lot of potential, both that we see from our customer side and our investor side. And also, if you look at the public retail market, they're loving these kind of companies. To give you an example, Jyoti CNC went public at like $800 million. If I remember it correctly, I think somewhere at around the 800 million kind of market cap. I think they closed yesterday at like $3.2 billion market cap. So the retail market loves it. Azad Engineering, which does similar precision components in the aerospace industry, they're a market cap of like $1.5 billion today. So there's a lot of interest and focus on this kind of engineering that's happening in India, which is great news for anybody who wants to do something in hardware or manufacturing. Especially the next 2 decades are very ripe. And look, China plus one is very real.
True.
I have seen people saying no, it's not. I can see it first hand with my business. It's very real. And we might be starting off with like the mid-level precision on that, but the intent of these companies that are moving to India is to go to the highest end of precision.
Correct. 100%.
So we did $1 million from Bloom 2019, and then mid last year we did a $7 million round from Peak 15, Ganapati Subramaniam, who runs a fund called Yali Capital, one of the most respected deep tech investors in the country. And Matthew Syriac, who's the head of Blackstone India, runs Florin 3 Capital. And we just recently, last couple of months ago, did a $13 million round from Peak 15 again and Stakeview Capital. And Enam Holdings also participated. And of course, a bunch of our previous investors like Bloom double down on us.
Correct.
But generally in the ecosystem, I have seen a bunch of I think there was a lot of talk and people are trying to do deep tech, but I think a lot more energy and time and patience needs to be spent in understanding what the company does or understanding the tech. And I think for us also at Ethereum, the reason I think things click for us is not just purely because of the technology. Because it's very difficult, given the bandwidth, because there's so many companies that are hitting these VC firms, it's very difficult for them to spend the kind of efforts and time and energy that you as a founder has done in building your product or understanding what the product does. But when they see a commercial takeoff, for them that's the proxy on which they judge. And when that happened, it was easier, and then it's like, okay, you might as well be a deep tech, but this is now a commercial manufacturing thing.
Right. Becomes easier to understand, right? Otherwise, in this space, you never know how long will you take to get out of that R&D mode and get to commercialization. So that's I think there. So for anyone starting out, CNCs you've done. What else do you think we can have from India, like machines, precision manufacturing, injection molding, or any such machines? What do you think are sectors which are interesting for anyone who's starting out now?
There are a bunch of things in manufacturing: casting, molding, machining, forming. If you just want to get into precision machining, get the machines to talk to each other. Do I really need an operator to stand on the machine every now and then? Can we go about palletization? Can I go about in robotics? Can my inspection be automated?
That's a pain.
My QC is a huge investment. People running a 3-shift in QC. Can all that inspection be roboticized? There are a bunch of things. But there's a lot of work to be done and starting from the basics from there. I think what I see from my interaction with a lot of early stage entrepreneurs now who want to get into manufacturing are not getting into the true depths of manufacturing. They're trying to be on the layer.
Right. Some application built on something.
Yeah.
Yeah.
And until and unless you get to the true depth of it, you're not going to have a very tight defensible moat. And that is something I don't see a lot of people focusing on, which I hope changes now.
True. And I think there is a large opportunity in that.
Yeah, like, I just think there's like, you need to get your hands filled with grease. That's the bottom like line.
Most of the folks who are also interested in doing manufacturing related things, what they try to do is, okay, we have camera systems. We'll create an AI layer over it, which just understands what that image is about. But then that doesn't create a complete solution. You will be ending up doing projects for companies and don't have a solution which could make you into a larger business. So I think you need to look at the whole vertical. How much money would you have raised, let's say, if you didn't have a cap? Or how much money do you think a venture like yours should raise when they are sort of going from the CNC, 3-axis CNC to 5-axis CNC?
$2 to $3 million.
2 to 3 million. 2 to 3 million, you would have been able to do things in parallel, get things right.
I think it's fundamental that an entrepreneur at that stage learns how to do it under $2 to $3 million. Otherwise, like, abundance is also like, you need to learn how to do this frugally.
Yeah. Agree.
These markets change, honestly, you don't know. And if this is the problem that you want to spend the best years of your life on, right, then you're looking at a very long term. So in fact, while I would say that I would have liked more money at that point in time, it would have made my life more comfortable. But it's also brought in like a very hard culture of frugality across the company today. And that's something we are very proud about.
Yeah, I don't agree. Those constraints sort of help shape the business as well. So if someone had to start a venture in CNC machine building, like what you've done, what should they know? How should they start? What all skills they need to really hone?
It's a very simple like thing you can build, and you'll find like multiple YouTube like videos on how to build it. It's a graph plotter, like an ink plotter. So basically, there's like, it just moves in X and Y. Z doesn't move, so the pen doesn't move. So there's a pen, which just you can like make it like a calligraphy machine. It's like a pen which is just like automated. It can draw your graphs. It can draw whatever diagrams. To build that is pretty, I think, it's not very simple. It's not very complex. It's somewhere in between. So you can like build a plotter to understand the basics of CNC.
Right.
And then when you want to go to the actual industrialization, then you need to be thorough with a couple of like scientific concepts. You need to understand how materials behave, right? Like our first models the structure would be built out of aluminum, but now they're all cast, right? So why we make that shift? If we have a structure that's like a bed has like a couple of gaps inside them, why is it that we've made those holes? And if we've made those holes, does that affect the dampening capacity of the structure? So you need to be able to understand what factors thermal influences play. So if the temperature in which the machine is housed like increases by 5 to 10 degrees centigrade, then how does that affect your accuracies? So you need to be able to understand a little bit about thermodynamics there. You need to be able to understand how different materials behave when they're being formed, when they're being shaped.
And that comes with experience and of course some study material, then but practical exposure needs to be there.
Yeah. You need to be able to understand how tolerances stack up. You need to be able to understand how to read and make mechanical drawings. You need to be able to understand how things are measured, quality certified, what are acceptable deviances, what are not acceptable deviations. You need to get a little bit of your hands dirty by running simple lathe machines, simple grinding machines, simple cutting machines. You need to put in a little bit of blood and sweat. Actually, no, you need to put in a lot of blood and sweat.
100%. Just confirming, both of you were mechanical engineers?
Look, both of us are actually electronics and communication engineers. And in front of Navin, I never say I'm an engineer. In front of his knowledge and his genius, I am not close to being an engineer. Yeah.
For the three-axis machine, how many folks you had in the team totally?
Two of us, me and Navin.
Just two of you. The three-axis machine is all you. And till 2018, how was that structure?
We had like 6-7 people who would help us with like. The whole team was like not more than 7-8 people.
Oh wow. You mentioned, of course, there was not a lot of help from consultants, but how did you end up doing your first hire as such? And what sort of skill set you were looking at? Were you able to find such people?
It's still quite difficult for us to find talent. But what we're able to do now, like I said, right, India has a good set of talent that has come because of the automotive machining industry. But they don't have the skill set or the high position. So we're able to take some of them and we're able to take a good chunk of that and then graduate that to higher end precision machining kind of talent. But to start off while building a team, it was very hard, man. It was very, very difficult because, especially also in the era when 2014 to like 2022, hardware startups, deep tech startups was not the place that youngsters wanted to go. Like even today, they're still like people still want to go on the software side. Mostly it's there. So what we started doing is we started looking at talent that were building your Baha SA racing. They were building car EV projects in college. So even today, my LinkedIn says hiring those who've broken something up, who've broken something open, and put them back together. That's more important. Not just opening them, you put it back together.
Actually, you don't realize, but that is a very good skill to learn early on. I mean, I think everyone I knew from, let's say, the robotics society of our college is still mostly doing something related to hardware if they have found the opportunity. I think those societies in college are actually very useful.
Like if you think about it today, one of the prime drivers at Ethereal is Sumit.
Yeah.
Sumit was the leader of his college's F1 racing team. Like sorry, not F1 racing team, but he was building those shell cars. And to go in the Shell Eco Marathon, he was going to Indonesia racing those cars. He was getting that car built. And today he runs a good amount of the show at Ethereal. So in fact today at Ethereal every year, we manufacture components for these racing teams in colleges pro bono. Yeah, we pick like 2 teams every year. And we usually prefer the tier 2, tier 3 colleges because they don't get that kind of look. If you've gone through 10 years of being beaten down by the world, you like to support the underdogs and oppressed even more. so,
No, but that's very good. Yeah, very good.
so we usually provide a lot of support. We do those components pro bono. And we try to, so like we just had one person whose college racing team we sponsored join us now. Just graduated and just joined us. But we did that pro bono work last year. So that's like a funnel that we are seeing is pretty effective. Yeah. So we've seen very passionate people come out of there.
Actually, I think back in the days when we were in college, probably we did not have enough opportunities for folks to sort of venture out and really get a decent package, in any of these sectors. Now I think that's changing.
So that's the thing, right? Like if you if you have to employ so many people in a country and you have to compete with software salaries, then you have to go on the high end of manufacturing. To go on the high end of manufacturing, you need higher end of your base level machines, which never existed in the country. So that's why I feel manufacturing has been on the mediocre pay stage. But if you start going on the higher end, you can start paying higher. And that's where I think this country will now move.
How has the blue collar workforce management been? Is it difficult? Is it easy? Or you took some time to figure it out?
Look, if you're taking care of people the right way, it's not a problem. If you are not, if you're going to get into the nitty-gritties of treating one person differently than the other, I don't view anything anymore as like blue collar, white collar. Everybody gets access to the same kind of facilities. Everybody gets covered under mostly the same, you know, we all have the same benefits, we're all entitled to it. So, but we're still at a very early scale, so I don't think I can comment too much on it. But till now, it's been okay. It's been fine.
Got it. Wanted to touch upon how a sales cycle in a B2B business like yours would work. How did you reach out to the first few folks? How long did it take to convert, let's say, the first customer, first large customer? And how does that work?
So, you know, ironically, what people would not believe that, okay, look, we built a multi-axis machine. We're not going to invest a huge amount of capex equivalent to like buying a luxury car for myself, like, a young startup company. Over here, the customers don't have like a huge hurdle to try us. Where like, say you have a precision component, right? They're like, and they'll throw us the toughest part. But they're like, look, if you build a 5-axis machine, this component is easier for you. Because you have like 400 different parts that go into your machine. This is just one component. You guys should be able to look at this. So that's how it started off, right? So we get these technical drawings. We make one or two of these. So the customers don't really have to invest anything to try for a trial batch. And the trial batch is just usually one or two or three or max of 10. Once we provide that, then the orders start flowing in. So we are actually very selective about who we work with. We work with very few customers. As of today, our customer count is in late single digits. Yeah. It's in late single digits, early double digits. That's it. But each of them are very, very large companies. To give you an idea of one of our largest accounts, this customer has a backlog order of $10 billion. B for a bat. His order backlog is $10 billion. That's how large these companies are. So we typically work with very large corporations. We work with very few, but we go very deep with them. Now, once that initial hurdle has gotten past where they're like, oh great, like, these components are coming on time. These are pretty complex components which very few people are able to service. They've also started sitting with us on their design cycles. So if it's a project that's like happening 2 years down the line or a year down the line, they're just taking our inputs now saying, hey, look, like guys, you guys understand machining. You guys understand how to build machines. And because designers build very visual things, you would know this. Designers create a lot of visual things which might not be the best for manufacturing. So we help them out like with inputs on change this, change that. And then we know that like a year down the line, it's most probably coming to us instead for us to make it. So we go very deep. We work with customers across US, Germany, Israel, India. And it usually goes by word of mouth. That, hey, you're doing for, like, to give you an example, right? Say, we're doing work for you. There are other people who are making in the health accessory space. Then they come to us. So we've done similar things happen to us in the aerospace side. Similar things happen to us in the defense side. So today, like we work with 3 different drone companies. We work with like 4 different thermal imaging companies. So we do components for all of them. So it usually goes that, okay, look, if you've done for them, and if you have all your certifications in order, so now the barrier for somebody to try us is very low.
Got it. No, makes sense. But very cool that it's majorly word of mouth and you don't have to do a lot of effort on sales side. You mentioned you reached out to 2, 3 folks initially.
Till like 3 months ago, sales was just me. Nobody. Now things are growing. So now we're trying to put a system. We have a very senior experienced folks from the aerospace industry. We have project managers. So now we have like a team taking care of all of that. But till like 2, 3 months ago, it was just me. It was just one or two cars. That's it. Like me and Sumit handling everything.
And typically, what do you see as the R&D phase versus the production? As in, you spend how much time in R&D itself with any customer?
Very little.
Very little.
Very little. Usually, the kind of customers we engage with are already in the productionized zone. When we get the first drawing, very little. Like 72 hours.
Oh.
That's it. That's also why they're coming to us. Because they're like, because they're like, these guys know how to look at complex components. So 72 hours, in some cases, if there are a lot of SKUs, takes a couple of weeks. But a single, just one, 72 hours, 48 to 72 hours, we usually get back.
Oh, that's very cool. Do you also exhibit your products somewhere? Are there any? There must be some manufacturing exhibitions anywhere. Right.
The machine tool shows, we've done it. We've done it. We've exhibited in Chicago. We've exhibited in Bangalore at Intex, which is like India's largest like machine tool show. So we do keep our machines there.
Got it. Got it. I really like the way you design the machines also. Typically, such machines would look, very engineering heavy. I really like that you put your logo there and it's lighting up. Looks like a customer facing machine, honestly.
It's almost a taboo to build it in black. You have no idea the number of people who come and say, you made a machine in black. When we said, so that's why actually when people come in now, I tell them that anything you see in black in this factory is made by us. Anything that's not in black is an ancillary helping QC instrument or a machine or something. Everything is because we have older generation machines, we have newer generation machines. We'll have another generation coming up in the next few months. They're like anything that you see in black is ours.
Got it. What about the ecosystem should we talk about? Anything left? No, right? Can't really do that. Can't have a podcast on that. But I think we'll conclude about.
We can have a podcast of that.
But not on this channel. Yeah. So Kaushik, what's next for you? You mentioned that there's a 3 lakh square feet factory that you're going to be opening up. Apart from that, are you looking at international expansion as well, or what are you planning? Of course, you make in India, but still.
Look, the larger vision, the goal here with Ethereal is, a few years down the line, any aircraft we step foot into, we want to say that we made a part onto it. Any person who's going for a health scan on an X-ray machine, we should be able to say that there is a part that Ethereal has made that's gone into this. That's the vision we're working towards.
Hope to see that soon, man. Be lovely. Great, Kaushik. Thank you so much. I think we've covered most of the things. I'm sure you must have gone through phases of ups and downs, and the last decade would not have been easier. Now, of course, there's a lot more support from the ecosystem, from investors, from the government, and the India manufacturing story as well. I hope your story helps and inspires others to build companies in a similar domain. Of course, yours is complex enough for no one to sort of try and enter as well. But hope the building journey becomes easier for anyone starting out. Thanks again.
Thank you.